Okay, so what we're going to look at now, and there's one problem like this, one or two, I think it's just one on my math lab. All right, what if it said this? What if it said f of x is equal to, I've got to find one that works out pretty well. I'm going to make this up, -4. So f of x equals -4. What they're asking is this. So remember here, that was, what's the y value when x was what? -3. So you look for where's x -3, so x is -3 here, here's the point, correct? And so there was the y value. The y value is what? -6. Now they're asking you if the y value is -6, I'm sorry, -4, what is the x coordinate? So that's the question. So if the y value is -4, find x. So the y value is -4, find x. So you gotta determine first of all, where is y -4? So on the y-axis, so remember we did the first one, f of -3 equals -6 equals what number, what value? We first of all located x equal -3. So here's on the x-axis where x is -3, right? And then we found the point. So we went down until it touched the graph. There's the point. You all agree? And the y value was -6. Okay. Now they're saying if y is -4, what's x? So now I'll go along the y-axis and I locate -4. -4 is here, correct?
Yes.
I go across. Remember previously I went down? I go across and I put points where the graph is for when x is, I'm sorry, y is -4. So there's this one. You all agree that this y value is -4?
Yes.
And you agree that this y value is -4?
Right.
Okay. What's this x right here?
-4.
What's this x right here?
-6.
Okay. So x equals -4 and x equal -6. Okay. So again, you got to know what this, how to read this. This says, what is the x value? What is the x value when y is what? -4. Now you know that this is y because f of x is the same thing as what letter? Y. So y equals -4. So when y is -4, what is x? So you go along the y-axis, locate -4, and then find out what points correspond to it. So it's these 2 points. So this y is -4, and over here y is -4. And all you got to do is tell me what the x is. X is -4, and x is what? -6. All right, let's look at this one. Over here, suppose we had, I got to pick one that's going to come out nicely. Otherwise, it will be a decimal. Let's do this one. So we're going to estimate. So this time, f of x equal 5. F of x equal 5. Find x. So in other words, remember what that means. That means what is the x coordinate when y is what? 5. So you go along the y-axis, you locate where 5 is, and then you determine the points that are associated with it on the graph. So here's 5 right here, right? How many points are associated with that 5? 2. There's this one, and there's this one. Yep. You agree it's these 2? Here's 5 right here, right? And then the points associated with it are these 2. You agree that this y value is 5 and this y value is 5?
Yes.
But they want the x coordinate now. What's this x coordinate? 2. And what's this x coordinate? 6. So x equal 2, comma, x equals 6. Okay? See how to read that? All right. Let's see. We got to do one that's a function, though. Number 10 is not a function. Number 9 is. So let's say number 9, we had this. We had f of x equal 2. F of x equal 2. Find x. So what do you think x equals? If f of x equals 2, remember that means that y is 2. So when y is 2, what is x? What is it? What do you think?
-4.
-4. Because here's y is 2, right?
Uh-huh.
There's only one point associated with it. That's this right here. What's that x coordinate? -4. Okay? What about this one? Let's say, let's go ahead and put that here. F of x equal 6. What's x? -2. Y'all agree? Because when y is 6, here's my corresponding point. That x coordinate here is -2. What about this? F of x equal? F of x equal? -2. X equal what?
2, 4, 5.
Yeah, so there are, how many of them? 4? You agree there are going to be 4 x coordinates?
Yes.
Because there's this one. What's the x coordinate? 2. Here my y coordinate is -2, but what's the x coordinate? 4? 4, right?
Oh, 2, 4, 5, and 6.
Yep. So x equal 2, comma, x equal 4, comma, x equal 5, comma, x equals 6. Okay?
You have to write it like that too?
On my math lab, I think on my math lab is going to be a line though. I don't think it'll be more than one x coordinate, but if it was more than one x coordinate, yeah, you have to separate it like that. All right. So any questions on that? So there's one like that in my math lab for that second section of 10.6. Now here's another thing I want to do with that section is this. Suppose we had this example, this function. Now you need your calculator for this. Suppose f of x is equal to 2x squared. Let's make it 3x squared. 3x squared minus 5x plus 1. Now you all know that if I say find f of -3, that's the easy kind. Substituting, you're going to substitute this integer, right? So substituting an integer is the easy kind. So where we see the variable x, you're going to substitute what? -3. So you're going to say, well, that's going to be 3 times -3 squared minus 5 times -3 plus 1. You all agree?
Yep.
All right. Now, when I do this term right here, what part do I do first? The exponent. -3 times itself is what? 9 times 3 is? 27. -5 times -3 is? 15. So plus 15 and then plus 1. And you just add from left to right. 27 plus 15 is, what's that, 40, 42. 42 plus 1 is 43. So f of -3 equals 43. You all agree?
Yes.
All right, B. This time, suppose I want to find f of 2/3. F of 2/3. So we see the variable x, and there's one in my math lab with a fraction, so that's why I'm doing this. Everyone we've done at this point was an integer. So don't make it difficult. So you're doing the same process. Where we see the variable x, you're going to substitute what? 2/3. I'm going to get 3 times 2/3 squared minus 5 times 2/3 plus 1. Right?
Right.
All right. Now, what is 2/3 squared? What fraction is that? 2/3 times 2/3. Oh, come on now. 2/3 times 2/3. 4/9, right? No, guys, come on now. 2/3 times 2/3. When you multiply fractions, you multiply numerators, multiply denominators. You may want to reduce first, but at some point you may need to reduce. 2 times 2 is 4. 3 times 3 is 9. So 2/3 times itself is what? 4/9. So I have 3 times what? 4/9. Okay, that's what I have. All right, and then I'm going to rewrite everything else over for right now. I'm just writing everything else over. Minus 5 times 2/3 plus 1. Y'all agree? Okay. Now, if you look at the operations you have multiplication, subtraction, multiplication, addition. So what do I do first? Multiplication. Let's do this one first. So you got to remember something from previous courses. This 3 times 4/9, this 3 is really 3 divided by 1. So 3 divided by 1 times 4/9. So how do you multiply these two fractions?
No.
What do you mean by cross multiply?
3 times 4 1 time.
Okay, so you can multiply the numerators just like you did this one, right? And then multiply the denominators. Or you could have done what first? Reduce. Now someone said the least common denominator. The only time you find the least common denominator is if you're adding or subtracting. If you multiply or dividing, you don't. Only when you add or subtract. So you could have reduced first, because 3 and 9 have what in common? 3. Now if you didn't reduce first, you could have said 3 times 4 is 12, and then 1 times 9 is 9, and then reduced at that point. What do 12 and 9 have in common? 3. So 12 divided by 3 is 4. 9 divided by 3 is 3. But you could have reduced first. If you reduce first, you would have said 3 divided into 3 is 1. 3 divided into 9 is 3. 1 times 4 is 4. 1 times 3 is 3. You get the same thing. Okay? So that right here, this right here is 4/3, correct? What is, and then subtract, because a negative times a positive is a negative. What is 5 times 2/3? 10/3, 10/15. Negative what? Yeah, it's 10/3, dude. What? 10/3. Okay, look. It's just like this one. 5 over 1 times 2/3. So it helps sometimes you put that over 1. Because if it's not over 1, it does confuse people. They tend to multiply both the denominator and numerator by it, and you don't. So it's 5 over 1 times 2/3. So you multiply numerators together. 5 times 2 is 10. And then 1 times 3 is 3. So it's 10/3. So minus 10/3 and then plus 1. And at that point, just use your calculator. So in your calculator, you just do this. You say 4/3. So 4 divided by 3. Minus, and then what? 10/3. So 10 divided by 3. And then plus 1. And then say equal. You get -1. Okay? You get -1. Now, let's suppose you had this, though. All right, suppose we had f of x equal -3x squared plus 2x minus 5. And let's suppose this time we want to find f of -3 fifths. F of -3 fifths. So wherever we see the variable x, what do I substitute? -3 fifths. So I'm going to get -3 times -3 fifths squared plus 2 times -3 fifths and then minus 5. You agree? All right. Now I've got to, in the first term right here, I got to figure out what -3 fifths squared is. So remember, -3 fifths squared means -3 fifths times itself. -3 fifths times itself. So what's -3 fifths squared? 9/25, right? You agree?
Yes.
Okay. 9/25, so that goes here. So I get -3 times 9/25. And I'm going to just write everything else over. So plus 2 times a -3 fifths and then minus 5. But all I did was just, at this point, was just figured out what -3 fifths times itself is. Now, if you notice, all I have left is multiplication, then addition, then multiplication, and then subtraction. So I do multiplication first. A negative times a positive is a negative. Now, how do you deal with -3 times 9/25? How might you want to write that -3? Okay, can I reduce first? No. So just multiply numerators. What's the numerators we multiplied? -27. What's the denominator? 25. So that right here is -27 divided by 25. Okay, then a positive times a negative is a negative, so I'm going to have a subtraction here. Or you could just say plus and negative, does not matter. Now what's 2 times 3/5? You all agree? That's going to be minus 6/5. Okay. And then minus 5. All right. At that point, I wouldn't take the time and find the LCD and do it that way. You have access to a calculator because you're not going to have time in a test to do all that. So use your calculator. So you're going to say negative 27 over 25. Now remember your negative button is right here. That's your negative button. So you're going to press negative. So it shows up negative right here. 27 divided by 25. Then I'm going to subtract 6 divided by 5. And then we'll subtract 5. And I'll press equal. So I get this decimal. In the previous one, I ended up with an integer. Here I have, this is not an integer, it's a decimal. It's still a rational number, but it's a decimal. All right, now we have to convert that back to a fraction. So remember how to do this? What do I press? If you have this calculator, what do I press? Second.
PRB.
PRB.
And equal.
And equal, and it gives you your mixed number. So my mixed number is negative 7 and 7/25, right? So remember what you did. If you didn't use this calculator, or if you have a different calculator, you need to look at your instructions how to convert a decimal to a mixed number. All right. So it writes as a mixed number. Now you can leave your answer as a mixed number, or you can write as a fraction, improper fraction. On my math lab, they may say write as a mixed number. They may say write as a fraction. If they say a fraction, then you have to convert this back to an improper fraction. So remember how to do that? 7 times, I mean, there are 2 7s, so you got to be careful which 7 we're talking about. You're going to take the denominator, you're going to multiply by the whole number part. Don't do the negative, though. 25 times 7 is 7 times 25. 175, and then I add the numerator. So plus 7, and I get 182. So this will be a negative, though. 182 divided by what? 25. Okay? Well, on the test, I wouldn't give you one with a fraction like this because you really don't have time, but on my math lab, they do. Okay? And on my math lab, if they tell you to write as a fraction, this is what they want. This is a mixed number. This is a fraction they want. Okay? All right. So when you do my math lab, just have those two in front of you. Mainly this one because the answer is going to be a fraction. Here, the answer was an integer that we did. Okay? All right. So then we have enough idea now how to do the second part of 10.6. So I'm going to assign that tomorrow. Now, there's still a couple of you, and I emailed a couple of you 2 days ago about that first section. Some of you had below an 80%. I looked again today, and you're still the same grade, the 2 of you. So I don't know if you're reading my email or not. But that first section is due tonight.
Mm-hmm.
All right, I'm gonna assign it tomorrow night for 3 of you. There actually one person hadn't started at all. The rest of you have. Most of you have 100s on that one.
10.3 is due tonight.
Yeah, 10.3. The first section I assigned 10.3. So I'm going to assign it tomorrow night, but that's the end. That if you haven't done it or haven't completed it, that's what you get. All right, and the other section is due when?
Tomorrow.
Both of them due tomorrow?
One's due tomorrow, and I think the other one's due on. No, they're all.
10.3 is due tonight by 11:59. 10.2 is due tomorrow by 11:59.
All right, so I'm going to fix that tomorrow. I'm going to assign what's due tonight tomorrow, and what's due tomorrow I'll give you until Wednesday to do it. But I think most of you have done both of them. And then the new one, I don't think any of you started it.
I didn't realize you added it. I did it today.
Yeah. I think last time I told you I was going to open it up. But now there are going to be 2 10.6s, though, because we talked about this.
I started, I just didn't figure out how to get my
I got like 20, I got up to like number 20 and it started asking me to enter a bracket and a parentheses. And I racked my brain and
Trying to
then
figure out
I
where it's
asked
located?
her, and she played with it while we were waiting on your class to start. She's like, oh, you do it manually. I was
Oh,
like, I remember that from last semester. I felt like I did it, but yeah,
no, that's all right.
I know how to do it now.
Well,
I
good.
got 4 questions I heard them.
Good. Doing stuff on computers is more challenging than doing it on paper.
My math lab is a pain in the rear.
It is.
Oh, it is. I know. I know, but we have to do it. It's required. And if you're going to pay the money, that much money, it's got to be a good percentage of your grade anyway. So that's why it's 13%. And it's easy, though, to get above a 90% on my math lab at the end of the year. So it's an easy 13%. Yeah. All right. So we were talking. So we talked about the last time we talked about the review for the factoring. So I think I gave you the 2 worksheets. I gave you 2 of them, right? All right. So that's due next class period. I think it was using distributed property in the FOIL.
Yeah.
All I wanted, huh?
We have 3, dear.
Oh, 3. Oh, the D part.
Yes.
It was 10.6 part D. That's right. All right, so there's 3. So 10.6 part D, and then the review worksheets for 13.1. 13.1 part A, 13.1 part B. If you weren't here last class period, I don't have any extra ones, so you just have to print it from Canvas. All right. Okay, so we continue talking about 13.1, and that's factoring. So some of this, the first part of this section is and it's just the very first part, is a review from 2 semesters ago in Math 97. All right, and you're going to need that idea when you do factoring, because the first thing you're always going to do with factoring, the first step always when factoring, and as you go along, you're going to learn those steps. The first step is always to find the GCF. And remember, what does GCF stand for? Greatest common factor. So the first step in factoring is to always find the GCF. All right. So before we can really talk about finding the GCF of an expression or a polynomial, we're going to talk about what a polynomial is. Let's talk about finding the GCF of numbers, a pair of numbers. Okay, so for example, this is number 2 on page 967. And here are my 2 numbers. My 2 numbers are 36 and 90. 36 and 90. And what I want to do is find the GCF of 36 and 90. So when you factoring polynomials, you're going to have to find a GCF. And in many cases, if there is a GCF other than 1, there's always a GCF. If it's 1 or something else. But if it's other than 1, then you're going to have to deal with things like this. So basically I want to ask, you're trying to find what's the largest number that these 2 have in common. The greatest means largest. Common factor. So what's the largest factor that these have in common? Okay, someone said 9. Is that the greatest common factor? That's the question. Do you remember how the last 2 semesters ago, do you remember what you did to kind of figure out what the GCF is? What you did, let me just kind of review this. What you did was, and 9's not the answer. 9's a common factor, but it's not the greatest. So it turns out that 18, which you figured out, 18 was the greatest. But here's what you do. You're going to rewrite this. You're going to rewrite this as a product of prime factors. So what you did to do that was you did the factor tree. Remember the factor tree? So you found 2 numbers whose product is 36. So what are 2 numbers whose product is 36? 6 and 6, right? But you can go further, because what you want to do is break this down into prime factors. 6 and 6 are not prime, they're composite numbers. But how else can you write 6? 3 times 2. So this 6 I can write as 3 times 2. And this 6 I can write as what? 3 times 2. And now these are all prime, so I'm done with 36. So 36 is 2 squared, because there are 2 factors of 2, times 3 what? Squared. So it's 2 times 2 times 3 times 3. So all of these being multiplied together, right? But I can also write it as 2 to the second power times 3 to the second power. So that's the prime factorization. So this is prime factorization of 36. So 2 squared times 3 squared. So if you couldn't look at this right away, and determine that 18 was the greatest common factor, then you have to do the prime factorization to help you. Now, for the most part, when we get really into factoring, the numbers won't be that big, so you'll be able to determine the GCF right away. But in this section, the numbers are a little bit bigger, so if you can't determine it right away, or if you're not sure what you say it is the GCF, then do the prime factorization first. And to do the prime factorization, it helps if you do the factor tree. All right, let's do 90. Give me 2 numbers whose product is 90. Any 2 numbers. You could say 10 times 9. You could say 3 times 30, right? You could say 45 times 2. It doesn't matter. Just give me any 2 numbers whose product is 90.
10 times 9.
10 times 9. Okay. Are any of these prime? No, they're composite, so I can break it down further. 10 is what? 2 times 5. 9 is what? Can I go any further? Nope, because they're all prime now. So 90 is 2 times 3 squared times 5, right? 2 times 3 squared times 5. Y'all agree? All right. Now, once I have the prime factorization, now I want to know what it is that they have in common. Because remember, in the word GCF is the word what? Common. So first of all, let's locate the prime numbers they have in common. They have a what in common? A 2. They have what in common? A 3. Do they have 5 in common? No. So that 5 will not be part of my GCF. Okay? Notice the word C, in the letter C in there means common. So far I know this. So far I know my GCF will have to have a factor of 2, and it will have to have a factor of what? 3. Will it have to have a factor of 5? No, because 5 is not common to both. It's only common to one of them. Once you list your common factors, then you got to determine, well, how many of each do I need? That's what you got to determine. How many of each do I need? Okay. So you're looking for the greatest that they have in common. Okay, the greatest they have in common. So listen to my words. For 2, how many factors of 2 do I have here? How many factors of 2 do I have here? 2. 2 times 2. So how many of them? 2. How many factors of 2 do I have here? 1. What's the greatest they have in common? 1. There's 2 and 1, one and the other. What do they share? Only how many of them? 1. So we have 2 to the first. Okay? Let's look at this one. Let's start with the 3. How many factors of 3 do I have here? 2. How many factors of 3 do I have here? 2. When they're the same, it's the easy kind. So how many do they share in common? What's the largest number? 2. So therefore, my GCF is 3 squared, which is what? 9. 9 times 2 is 18. That's your GCF. All right. So let's suppose though, come on, watch this. Let's suppose I give you this number, whatever number this is. Let's suppose it's 2 times 3 cubed times 7. That's my first number, number 1. Whatever it is, number 1. I can figure it out. I can say on my calculator 2 times 3 squared times 7, that would be your number. But whatever it was. Number 2, let's say, has this prime factorization. 2 to the 5th times 3 squared. Let's say that's all we had. Okay? But let's just... Now, you agree I didn't actually indicate what the numbers were, but you can tell me what it is. How can you tell me what this number equals right here? Use your calculator. 2 times 3 squared times 7, whatever that is. But it doesn't matter.
Squared or cubed? Cubed.
I'm sorry, 3 cubed. I'm sorry. All right. Now, the GCF, though, your GCF in the word greatest common factor is the word common. So you got to denote the prime numbers they have in common. They have what in common? A 2 and a 3. They don't have a 7, right? Now you got to determine what's the greatest of these common factors. I have how many factors of 2 in the first one?
1.
How many factors of 2 in the other one? 5. So I have 2 in this one, 5 in that one. What's the greatest that they share? 1 of them. Do you understand what that means? So that's 2 to the first. Over here, how many factors of 3 I have?
3.
How many factors of 3 do I have?
2.
So I have 3 of those, 2 of those. What's the greatest that they share? 2. So what's the GCF? 18. So it's, in this case, it's still 18. Yeah, I didn't mean it to be 18. It just turned out to be 18. But you understand how to find it? All right, let's do one from the book. Let's do another one. So this is going to be number 6. Let's look at number 6. Number 6, you have 15, 25, 27. 15, 25, 27. So when factoring polynomials, the first thing you're always going to ask yourself is, what's the GCF of the numbers first? The coefficients. So let's say that when we get to that point, these are my coefficients. It's 15, it's 25, it's 27. I want to find the GCF. Can you look at that right away and tell me what you think the GCF is? What's the largest number that goes to the 15, that goes to the 25, and that goes to the 27 evenly? Huh?
3.
Okay. Does 3 go to 25? No.
I'm gonna say 1.
GCF is 1. GCF is 1. No other number goes into all 3 evenly. You can't just look at 2 at a time. You got to look at what? All 3. Now let's suppose you didn't see that the GCF is 1. Let's do the prime factorization. 15's easy. You don't have to do the factor tree. What two prime numbers multiplied together is 15? 3 times 5. Okay. 25 is easy. What two numbers multiplied together is 25? 5 times 5, which is 5 what? Squared. Okay. 27. What two numbers multiplied together? Well, 27 you may need to do a factor tree. Let's do a factor tree. 27 is 3 times what? 9. 9 is what? 3 times 3. And so therefore 27 is 3 to what power? The what? The third, right? Okay. So 27 is 3 cubed. All right. Do those 3 numbers share any prime numbers? No, prime. One's not a prime. One's not a prime. But let's talk about prime for right now. Do those 3 numbers share any common prime factors? No. No. Now, one's not a prime. What's the smallest prime number? Your prime numbers. 2. Your prime numbers are 2. Remember, your prime numbers are numbers, whole numbers whole numbers whose divisors are 1 and itself. So 2, 3 is 5 prime? Yeah. So 2 is the only even, right? 2 is the only even prime number. Is 7 prime? Yep. Is 9 prime? No. Because the divisors of 9 are 1, 9, and also what? 3. 11 is, and so on. Okay? All right, so those are your prime numbers. But one's not prime, but 1's a factor of every number. So 1's a factor of 15, because 1 times 15 is what? 15. 1's a factor of 25, because 1 times 25 is 25. And 1's a factor of 27, because 1 times 27 is 27. So the largest factor that they do have in common is what? 1. So the GCF is 1. Right. So there'll be instances where when you factor polynomial and you ask yourself, what's the GCF? The GCF is going to be 1. You're going to see that. So we're going to say, well, the GCF is 1, so let's go to the next step. Right, let's look at number 4. Number 4. Okay, number 4, you have 30, 75, and 135. 30, 75, 135. Now that will make it a little bit more challenging to determine what the GCF is. I'm sorry. Okay. 30, 75, 135. This may be a little more challenging because of the 135. What do you think is the largest common factor of those three numbers? Five?
15.
15? All right. So if you're not sure, or if it gets too big for you, then do the prime factorization. Prime factorization of 30, if you need to use a factor tree, that's going to be 5 times 6. And 6 is what? 3 times 2. So do you all agree that 30 is 2 times 3 times 5? Okay. 75, let's do the factor tree for that one. 75 is 25 times 5, right? And, I'm sorry, 25 times what? 3, excuse me. 25 is 5 times 5, and so the factor tree for 75 will be 3 times 5 squared. And notice I'm aligning my common prime numbers. See what I did?
Mm-hmm.
And then for 135, that's going to be 5 times, so when you calculate 135 divided by 5, 135 divided by 5, 27? You see what I did? 5's prime, but 27 is not, so I can break that down. 27 is 3 times 9. 3 is prime, 9 is not, but 9 is what? 3 and 3. So my prime factorization for 135 will be 3 to the third power times what? 5. Okay. All right. And now I know that GCF in the word greatest common factor is a word common, so I'm going to look to see if these numbers have any common prime numbers. Do they? 3 and what? 5. So far I know that my GCF will have a factor of 3 in it, and will also have a factor of 5 in it. But the question is, how many do I need? I have how many factors of 3 here?
1.
How many factors of 3 here? How many factors of 3 here? 3. So I have a 3, and 3 of them. How many? What's the largest they share? 1. They share 1. Y'all agree? All right. Now I want you to notice as we went through this, when you do write it as an exponent, it's always going to be the smallest exponent. You see that? So 3 to that, and what's the smallest exponent you see? 1, 1, 3, 1. You see that? Okay. So if I go back over here just to show you what I mean, let's do the one that I had the 18. What was it? This one? So remember we said the GCF had a factor of 2 in it and a factor of 3. For the 2's, that's 2 to the first, that's 2 to the fifth. What's the smallest exponent? 1. So the 2 to the first. Here, that's 2 to the third. I'm sorry, 3 to the third, 3 to the second. What's the smallest exponent? 2. So that's what you saw there. Okay. So for 5, this is 5 to the first, 5 to the second, 5 to the first. How many will I need? Just 1. So it's a GCF. 15. Okay. Now you remember that the idea that exponent, that's going to help you with the letters now. So look at number 10. Let's talk about number 10. So in your polynomials, you're going to have terms that are going to be a variable raised to a power, and you're going to have to find the GCF if there is one other than 1. So y to the 8th, comma, y to the 10th, comma, y to the 12th. So the question is, what's the greatest common factor of those 3 expressions?
2.
All right. So let's think about this. This term right here has how many factors of y? 8. So I have 8 y's up there. Remember how I was doing it earlier with the numbers? 8 y's. The next one has how many factors of y's? 10. The next one has how many factors of y's? 12. What's the largest that they share? 8. So what's the GCF? Y to the 8th. GCF is y to the 8th. Kind of makes sense because we talked about we have to use the one with the smallest exponent. This is 8, this is 10, this is 12. I need how many? 8. So y to the 8th. Okay? Y to the 8th. All right, number 8. What do you think about number 8? You have x cubed, comma, x squared, comma, x to the 5th. What do you think the GCF is?
2.
Don't say 2. Say what?
X squared.
X squared. X squared. You agree? All right. Number 12. You have p to the 7th, q times q, comma. So you're going to have polynomials with more than one variable. P to the 7th times q, p to the 8th times q squared, comma, p to the 9th times q to the 3rd power. All right, write this down. So p to the 7th times q. The other term is p to the 9th. I'm sorry, p to the 8th times q squared. And then p to the 9th times q to the 3rd power. Just like before, let's start with the p's. In my GCF, will I have a factor of p in it? Remember, it has to be in all of them. Is p in all of them? Yes. So I know I'm going to have a factor of p. And the question will be, how many of those will I need? All right, we'll do that in a little while. Will I have q in my GCF? Yes, because there's a q in what? All of them. All right, let's talk about how many I need. I have how many p's, how many factors of p in that first one? 7. How many in the other one? 8. How many in the other one? 9. What's the largest that they share? 7. So I need p to the 7th. Let's talk about q. I have 1 factor of q, I have 2, and then I have 3. How many do they share? Just 1. So that's your GCF. P to the 7th times q. All right, 14. Okay, 14. You have this. You have 20y, comma, 5. 20y, comma, 5. So think about what you think the GCF is and write it down. Let's see if what you wrote down is correct. What do you think the GCF is? Write it down. Any of you want to share what you think it is? Go ahead.
It's 5.
5.
You don't think it's 5y? Why not?
Because there's only Y on one of them.
All right, good. GCF is what?
5.
5. GCF is 5. So what you do, now notice that this situation where you have a term that has a coefficient other than 1 and a variable. So remember your GCF, you do the numbers first. So what's the GCF of 20 and 5? That one's easy. It's just what? 5. In order for the GF to contain the variable has to be in all of them. And it's not. It's just in the first one. It's not in the second. So the GCF is just what? It's just 5. The GCF. All right, knowing that, let's look at 16. 16, you have 32x to the 5th. 32x to the 5th. And then the other one is 18x squared. All right. So for the GCF, do the coefficients first. What's the greatest common factor of 32 and 18, do you think? What do you think?
8.
Does 8 go to 18 evenly? Nope.
6.
Does 6 go into 32 evenly? That's what you got to ask yourself, okay? All right. So y'all struggle with this, right? So if you're not sure,
Do the tree.
do the tree.
I can't do the tree.
Do the tree for
Yes, you can.
It's not 4 either.
No, it's not 4 either.
See?
It's 2.
Do the tree.
Do the tree. 32,
2x to the second. We ain't
it'll be 2x to the second, yes. 2x to the second. But you for the most part, you were having trouble with the coefficients. The variables are easy. It's the coefficients that you're struggling with. So do the tree. 32, give me two numbers whose product is 32. You could say 16 times 2. You could say 2 times 16. You could say 8 times 4. It doesn't matter. Just give me two numbers. So if you say 8 times 4, you got to keep breaking it down until you get prime numbers. This 8 is 4 times what? 2. This is prime right here. So I stop for this branch. For this branch, 4 is what? 2 and 2. So those are prime, so I'm going to circle them to remind me that I need to stop. This 4 here is what? 2, 2. So I'm done with the prime factorization for 32. So for 32, it's 2 to the 5th. Let's do 18. Give me two numbers whose product is 18. 6 times 3, 9 times 2, it does not matter. 3 is prime, so I'm done with this branch. 6 is not, so that's what, 3 times 2? I'm done. So 18 then is 2. I'm aligning my common primes times 3 what? Squared. Okay? Now let's talk about GCF. The GCF, remember they have to share something in common. So am I going to have a 3 in my GCF, a factor of 3? No. I'm going to have a factor of 2 because they share 2. Question is how many?
So why do you count the 2 under the 8? Because it doesn't have another leg.
Right. That's your prime number.
The 2 under the 8. You mean here? Oh, because it's prime. Because if you look at it, 2 times 2 is 4. 4 times 2 is 8. Right? 2 times 2 is 4, and 8 times 4 is 32. So you have to use all of them. Understand? Okay. But do you see that it's just 2? So the GCF is 2. So if you needed to do the prime factorization using the factor tree, then do that. Now notice though, some of you were saying, let's say 6. You're not being very careful when you say 6. You got to ask yourself, yeah, 6 goes into 18, but does 6 go into 32 evenly? And it doesn't. So it has to be a factor, meaning it's got to go into it evenly. 9, you said 9. 9 goes in 18, but 9 does not go into 32. Okay? So the GCF is just 2. That's your question on that part. All right, let's look at this one. So this is going to be number 20. Number 20. You have 15y squared, comma, 5y to the 7th, comma, and negative 20y cubed. So for the most part, they're going to be easy numbers to deal with. They're not going to be difficult numbers, difficult coefficients to deal with. So the coefficient, let's do the coefficients first. What's the GCF of those coefficients? 5. Now, one of them is negative, right? But let's just make it positive unless they tell you to make it negative. So always make the GCF a positive coefficient. So 15, 5, and negative 20, the largest common factor is what? 5. So there's no difficulty there, right? Now, what about your variable? Do you need any? Yes, because there's a y in all of them. How many do you need, though? 2. So 5y squared. That's your GCF. (22). You have 7x cubed, y cubed, comma, negative 21, x squared, y squared, comma, and then 14x y to the 4th. The variables are easy. The variables are easy. Coefficients is challenging some of them. But this is easy one right here. 7, 21, negative 21, and 14. What's the GCF? 7. No difficulty there. Now the variable. Do I need a factor of x?
Yes.
How many? 1. Do I need a factor of y?
Yes.
How many? 2. So that's your GCF. Okay? And then finally, let's look at 24. For that part, 24, you have 40 x to the 7th, y squared, z, that's a z. So 40 x to the 7th, y squared, z, comma, and then 64 x to the 9th, y. Now the coefficients, they're not difficult. You could probably look at it and tell me what you think the GCF is for the coefficients. 8. It's 8. So some of you may need to do the factor tree, but it's 8 because 8 goes into 4 and 8 goes into 64, right? 4 is a common factor, but is it the greatest? No. 8's the greatest. But once you get the coefficient, the rest is easy. You're going to have 8. Do you need any x's?
7.
7 of them. Do you need any y's? No? Yeah, you do. 1. Do you need any z's? No. So it's your GCF. 8x to the 7th times y. Okay. All right. Now, let's talk about how you're going to use this now. All right. So here's how you're going to use it. Okay. This is number 26. So now the direction is going to say this. Let me write 26 out first. So here's 26. It looks like this. 18a plus 12. We're going to start with the simple one. And the directions are going to, well, in the end, the directions will just say factor. The directions will say factor. Okay? Directions will say factor. And when you factor, the first thing you always want to do is look for a GCF. Now listen carefully. What are my terms? In your mind, now you don't have to write this down on a worksheet or a test because some of you can look at this at some point and tell me what the GCF is. But we got to find the GCF first. What what are my terms, though? This term is 18a, and this term is what? 12. What's the largest number, the largest factor that goes in 18 and 12, do you think? 6. 6. Do you need any variables? No. So the GCF is just what? 6. Okay, so that's the first thing you have to do, was determine the GCF. Now, once you find the GCF, you got to think of that distributive property that we did the other day, that worksheet. Okay, so now you're going to take the GCF, you're going to put it out in front, and you're going to ask yourself, 6 times what will give me the original polynomial back? 6 times what's 18a? 3 what? 3a. Plus 6 times what is 12? 2. And there's your answer. Okay? There's your answer. So the GCF goes in front, and you're going to write it as a kind of like a distributive property idea. Okay? So that's factoring. So the first thing you do in factoring is always look for GCF. You're not always going to have a GCF other than 1. But if you do, that's what it's going to look like at that point. So you find the GCF. Okay? Once you know the GCF, then you're gonna put out in front, you're going to put parentheses, and you ask yourself, 6 times what is 18a? 3a. That's distributive property. 6 times what is 12? The answer is what? 2. Distributive property. Okay? So that's factoring. So factoring is where you write as a product. So was I able, factoring is to write as a product. Remember factors, product. Was I able to write this polynomial as a product? Yes. 6 times 3a plus 2. Okay? All right, let's look at 28. I have 42x minus 7. 42x minus 7. What's the first thing you got to do in factoring is to find the what? GCF. GCF is 7. Y'all agree? Okay. GCF is 7. So I know that GCF is 7. Once you find the GCF, you're going to think the distributive property. So you're going to say 7 times, and you're going to put something in parentheses. Whatever you put in there has got to come back and give you the original polynomial. 7 times what's 42x? 6x. Minus 7 times what is 7? 1. So there's your answer. 7 times 6x plus 1. You factored this polynomial. So remember, polynomial means many monomials. So in this case, terms. So this polynomial had how many terms? 2. And when you factored it, you wrote it as 7 times 6x minus 1. So factor means to write this as a product, and I did. I wrote it as 7 times 6x minus 1. 32. You have 5x squared plus 10x to the 6. 5x squared plus 10x to the 6. So keep that idea in mind what we're doing. So first of all, find the GCF. You got to do that first. In terms of the coefficients, what's the GCF? Coefficients. 5. 5. Now let's do the variables. So it'll be 5 what? X squared. So once you get that, the rest is not that difficult. You got to think the distributive property in your mind. So the GCF goes out in front. So you can say it'll be 5x squared times, and now you're going to think about, well, what needs to go inside that parentheses? Be careful. Oh, I see what you're saying, 1. But it's not just 1, right? Some other stuff, though. 5x squared times what is 5x squared? 1. Plus, y'all agree? 5 times what is 10? 2. Now, remember, when you multiply like bases, let's think about this. When you multiply like bases, we do these exponents. You add them. Okay. X squared times what gives me x to the 6. So x squared times x to the, not third, you add exponents. So what? You said third, right? So I'm gonna put x cubed. She said 2x cubed. That's what she said. So let's think about 5x squared times 2x cubed. When I do the distributive property, always thinking about the distributive property. 5x squared times 2x cubed. What's 5 times 2? 10. What's x squared times x cubed? X to the 5th. Is that what I wanted? No. I wanted what? X to the 6th. So it cannot be, that's not what I wanted. So it can't be x cubed. It has to be what? X to the 4th. Because x squared times x to the 4th is what? X to the 6th. Okay, let's do another one, variables in it. But notice it's just a distributive property. So when you factor out the GCF, you're just thinking about the distributive property. All right, let's look at this one. This is going to be number 38. 968. Page 968. 968. Okay, number 38. Suppose you had this. 12x cubed plus 16x squared minus 8x. So 12x cubed plus 16x squared minus 8x. Find the GCF first. Now that part should be easy now. 4 what? X. 4x. Y'all agree?
Yes.
I'm hoping you all agree at this point. 4x. All right, where does that go? Out in front of the parentheses. So 4x times, and then the parentheses. Now listen carefully. How many terms does this polynomial have? 3. So you better have 3 terms inside the parentheses. Okay? So think distributive property. 4x times what is 12x cubed? 3x squared. 3x squared. Because 4 times 3 is what? And then x times x squared is x cubed. Plus 4x times what is 16x squared? 4x. Okay? 4 minus, and then 4x times what is 8x? 2. Just 2. Okay? That's your answer. That's your answer. So use the distributive property to check. Multiply like bases, add exponents. So 4 times 3 is 12. X times x squared is x cubed. 4 times 4 is 16. X times x is x squared. 4x times 2 is 8x. Okay? All right. So there's a couple more we're going to do with this, and then let me see if I can give you any worksheet on that. Let's see. Yeah, I can. Okay. So this is part C. So look carefully. So number 1, you're going to find the GCF of these numbers, right? Mm-hmm. If the GCF is 1, you're going to write what? 1. Okay? We talked about, now this is an easy one because it's just variables. These are just variables, right? Yes. That's easy. These are variables and coefficients, so that's not too bad. There's a negative there, but you're going to put the positive, right? Here's one with 2 variables in it. Talked about that. And then here's one with 3 variables and 2 variables. Talked about that. So y'all can do that one, right? Okay. 13.1 part C. 13.1 part C. So that's your 1 week from today. I can't give you part D because part D involved a little bit more of what we were doing with the polynomials. So I have to wait on that. But you can start on part, I mean you can do part C. It's really not that bad, guys. You just gotta know the distributive property. It's just distributive property. Um, okay, so is that the roll?
Yes, and then that was the extra copies. This one will be due next Thursday.
Yeah, 1 week from today, so the 7th, February 7th. All right, so I'm going to sign the second part of 10.6 tomorrow. And then My Math Lab, which I won't be able to do it, change it tonight. I'm going to have to change that tomorrow. But you still have until midnight to do it. If you go around 1 o'clock and do it, it's not going to be open. So I won't be able to change it until tomorrow. So the one that's due tonight is due tomorrow, and the one that's due, what did I say, tomorrow, I gave you until what, did I say? The 5th? Okay. All right, so, that's it. All right, have a good weekend.